Hello everyone, and a very good morning to all my friends and myself. My name is Sharnishwaran Nair, Analaki K. Vijendran, and my metric number is 1980-20F1005. I'm here for the case study 1 presentation for cloud computing. Based on the case study, my topic is RAID, Redundant Array of Independent Disks. Today I would like to explain about what is RAID levels, and what are the advantage and disadvantage of each RAID. What is RAID? Storage is very important part of fault tolerance. If something happened to a company's data, such as a disk failure that result in data loss, then that could have a serious impact on how the company performs. We need to make sure that if a disk fail, that no data loss could occur. One of the best way to prevent data loss is RAID. In RAID setup, the data copied on a multiple disk, so that in the event of this failure, no data would be lost. Now we talk about the RAID levels. Firstly, RAID 0, stripping. RAID 0 is not fault tolerant. It actually increases the chances for data loss. Data is stripped across multiple disks. All the data will be lost if one of the disks fail. The advantage of RAID 0 is always faster than a single drive. RAID 1, mirroring. RAID 1 is fault tolerant. Data is copied on more than one disk, and each disk has the same data. Data will not lost because the other disk will have the duplicate copy. It's definitely safe. RAID 2. RAID 2 is RAID configuration used to stripping across disk, with some disks storing error checking and correcting ECC information. RAID 2 has no advantage over RAID 3 and is no longer used. RAID 3, parity on separate disk. RAID 3 is a RAID configuration that uses a parity disk to store the information generated by a RAID controller instead of stripping it with the data. Because the parity information on a separate disk, RAID 3 does not perform well when tasked with numerous small data requests. RAID 3 is a better choice for applications that have long sequential data transfers, such as streaming media, graphic, and video editing. RAID 4. RAID 4 is RAID configuration that uses a dedicated parity disk and block level stripping across multiple disks. Because data is stripped in RAID 4, the record can be read from any disk. RAID 5. RAID 5 is probably the most common setup that is used because it's fast and it can store a large amount of data. Data is not duplicated, but it's stripped across multiple disks in a RAID 5 setup. There's another very important piece of information that is being evenly spread across all the disks, and this information called parity. Parity is used to rebuild the data in the event of disk failure. The disadvantage of RAID 5 is it's reduced the collective amount of data that can be stored in the array, because the entire disk is used to store parity. RAID 6. This technique is similar to RAID 5, but parity is spread twice on all the disks, so it can be handled two disk failure at the same time. The use of additional parity enables the array to continue functioning even if two disks fail together. However, this extra protection comes at a cost. It's expensive. RAID 6 always often have slower write performance than RAID 5 arrays. Finally, RAID 10. Strip plus mirror. RAID 10 is combination of RAID 1 and RAID 0. This level is often referred to as a RAID 10, which offer higher performance than RAID 1, but at a much higher cost. RAID configuration that combines this mirroring and this stripping to protect data. It requires a minimum of 4 disks and strip data across mirror pairs. As long as one disk in each mirror pair is functional, data can be retrieved. So that's all from me. Thank you for watching this video. I hope you enjoyed the video. Bye.